Okay. Now every node is linked to its own list that contains the names of all other nodes that are adjacent to it. That means which is directly connected with that node. Okay. Now it provides ease to follow and clearly show the adjacent node of a particular node. That means whatever the nodes are present as adjacent node, that value we can show or we can identify from that matrix. Okay, now here we had discussed this adjacency list. So that means A can directly connected with B, as well as B can, A can directly connected with C. Okay, now the next adjacent node or vertex is B. So now what are the adjacent node of B? So we have path from B to D as well as B to C. So we can define the path like B, C and B to D. So this is our, you can say, the adjacent node. Now what are the adjacent node of C? So C can only connect with D. So this is the adjacent node of my C. Now what is the adjacent node of my D? And for D, we have adjacent node like A and B because we have a direction from D to B and D to A. So that is known as your adjacent nodes. And this list is known as, for this G graph, we have adjacency list like this. Now for this is for undirected graph and this is for directed graph. So if we have undirected graph, so A can connect with B as well as D. Clear? There is no any direction, but it can connect with any edge, right? So this A is connected with one edge, A is connected with the another edge. Now B can connect with A, C as well as D. Now C can connect with B and E. So the adjacent nodes are B and E. Now here for D, D can connect with A, B as well as E. And E can connect with C and D. Right? But here we have a weight as well as the directed direction also. Right? So we can enter that value over here in this list. Now, elementary graph operation. So how to traverse a graph? There are two standard methods, breadth first search and depth first search. Now BFS uses the queue as a temporary data structure for further processing, and while your DFS uses the stack. Okay. Now BFS is a graph search algorithm that begins at the root node and explores all the neighboring nodes. Now then, for each of these neighboring nodes, the algorithm explores their unexplored neighboring nodes and so on. That means we have to visit the every node, but whatever the nodes are unexplored, we have to explore that node first. मतलब कि जिसका हमने विजिट अभी नहीं किया है उस नोड को हम पहले एक्सप्लोर करेंगे, उसके बाद दूसरे वाले को. Now graph may contains cycle, so we may come to the same node again. So to avoid processing a node more than once, we use a variable status. That means we are using one status variable. That means if status is equals to 1, then we had already visited that element. So graph may contain cycle. So maybe it's something like this, starting from, you can say, A. So A to C, C to G, G to H, H to E, E to C. So this means it is performing one cycle, right? So according to this, we have to avoid this situation. So that's why we can use this status variable, right? So if I'm visiting one node already, then we don't require to visit that node one more time. Okay. Now next, status 1, 2 and 3. So if my status is equals to 1, that means it is ready to visit. So the initial state of the node is equals to n. Now 2 is for waiting. So node N is placed on the queue or a state and waiting to be processed. Now 3 processed. Node N has been completely processed. So if my status is equals to 3, we have a status like 0 and 1. Okay, so if 0, student absent, if 1, student is present. Something like this. Okay, now during the execution, we use the two arrays, queue and origin. Now, while queue is used to hold the nodes that have to be processed, that means अभी उसका visit हमने नहीं किया. Now, origin is used to keep a track of the origin of each edge. Now, we have that algorithm that how we can traverse our graph using the breadth first search algorithm or breadth first search technique. Now, step number 1, set our status is equals to 1. So, ready state. Now, for each node in a G. So, now, right now, my every node contains status equals to 1. Now, step number 2, enqueue the starting node A and set its status equals to 2. That means start node जहां से भी आप अपना विजिटिंग करना स्टार्ट करोगे उस स्टेट का सॉरी उस नोड का स्टेटस हम 2 कर देंगे. दैट मींस it is in a waiting state. Now step number 3, repeat step 4 and 5 until queue is empty. Now step number 4, dequeue a node n. Dequeue, that means deletion. Process it and set its status equals to 3. Okay, so that means it's already processed. Now step number 5, enqueue all the neighbors of n that are in the ready state whose status equals to 1. And afterwards, if you want to visit that node, set their status equals to 2. That means waiting state. Okay. And one more time, go over here, check the if condition, like if my queue is not empty, we have to follow the same situation. Okay. Now this is one of the example. Now in given example, we have a directed graph with us. Okay. So first we have to make the adjacency list. Now, if you want to make the adjacency list, what is the first step? Okay, so first step is write down the every vertice's value in the list wise. So we have A, B, C, D, E, F, G, H, and I vertices with us. So I have just write that neat. Now starting from A node, starting from this A vertex, I need to find the adjacent node of that particular vertex. So adjacency list of A is B, C and D. B, C and D. Now B. Out edges. Outward edges are only connected with E. So that is E node as adjacent node. For C, G and B. Now for D. D for C and G. For E. E से E कितने नोड के साथ कनेक्टेड है? डायरेक्टली कनेक्शन. C and F. Outward edges देखनी, inward नहीं. Now F. F is connected with C. Yes, as well as H. Correct. Now for G. G के लिए I, F, H. I, F and H. Correct. Now H के लिए आपको देखना है adjacent node E and I. E and I. And I के लिए F. Correct. Now starting from A node, my queue is starting with A. Okay, now origin is equals to null क्योंकि अभी उसका status 2 नहीं हुआ है. Right, my front and rear both are pointing at the first location. Okay, now we are trying to make the queue. Now first step, according to the adjacent node, we have to make the entry of that particular nodes in the queue. So now my A node adjacent nodes are B, C and D. Make that status is equals to 2. That means B, C and D. Now the 3 of nodes are in a you can say the uh, process, you can say the waiting state. Okay, now if I'm making the entries, that means my rear is going to pointing at this location, D location, right? And front is equals to this. Okay, now origin is A, so I am starting from A only. So now my front is equals to 2, that means B. So now next time you have to take the adjacent list of my B. So B node adjacency list are E only, so E is not visited, so we can enter that E over here. Now my rear is pointing over here and my front is incremented with 1, so this one. So now my origin will become C, right? A I had discussed, B we had discussed. Now my origin is equals to C. So now go over here. What are the adjacency list of my C? B and G. So B we had already taken. So no requirement to take B one more time. So this is C and G only. Okay. Now we must have to take B also. So now increment, next time increment my origin with 1, so E. Okay, so now what is the origin, you can say the adjacency list of my E. So E adjacency list are C and F. So C we had already taken, right? Origin is equals to C we had discussed, that means C is also included. Now we have to take your E, right? So E adjacent nodes are C and F, so we must have to include F because C is already visited. Okay, now my front is equals to 6, so that is F. So what are the adjacency nodes of F? C and H. C we had discussed, now it's time to take the H. Okay, now my front is equals to next node, that is H. So what are the adjacency list of my H? E and I. So we must have to include that. Sorry, I forgot to take this G. Sorry. Okay, so what are the adjacents of G, F, H, and I? So now enter F. Did we find? Did we had taken F? No. So we must have to enter F, H, and I. That are the origin of my G. Okay, so now my front is equals to 7. Now this is my 7. 1, 2, 3, 4, 5, 6, and 7. This one. Okay, now check the adjacency node of F. This is C and H. So repeated, no need to make the entry. Now go towards the next one, that is H. So H is also taken, E and I. So we had already visited that nodes. Okay, so no need to take this one. Okay, and last we have to visit this I. So what is the adjacent list of my I? That is F. So F is also visited. Okay, so now backtrack from I using origin to find the minimum path of T. Okay, so we have to start backtrack. Okay, so if I am backtracking, what we have to do? We need to DQ as well as the NQ. Okay, according to the origin. So what are the origin nodes? So we have origin node like A, B, C, and G. But if we have to find the minimum path, we must have to backtrack. Okay. Now, how can you find like this are the perfect method or not? So if you are seeing over here, like A adjacent nodes are B, C, and D. Now for E, we have to take the next one, that is E. Now for E, we are trying to find out the next adjacent node of E, that is my C and F. Okay. For C, if we are taking the next adjacent node, that is G, because we had already taken B. So what we are trying to do, we are not moving from top to bottom, but we are trying to find the traversing from this side to this side. That means we are finding the breadth first search, not the depth first search. We are trying to find the breadth of my graph. Okay, so that is the main aim behind this. No, okay, so we have a smallest path from A, C, G, and I. A, C, G, and I. Right, so using this we can achieve the minimum, achieve the traverse of entire graph with every node traversing. Okay, we can visit the every node. Okay, now what are the applications of breadth first search algorithm? So finding all connected components in a graph G. So we can find the every connected nodes of particular vertex in a graph G. Now finding all nodes with an individual connected components. Individual connected components, that means for particular B, I am finding the adjacent node. Then for particular C, I am finding the adjacent node. But we are not trying to go in a depth, but we are trying to find the traversing from that siblings. Now finding the shortest path between two nodes, U and V, of an graph. Okay, now we have a next, that is depth first search. So here we are trying to use the queue. Okay, so in a queue we can follow the whosoever is come first, we can take that node as you can say the next origin. So first in first out. Now here in this depth first search we need to follow the method like stack is following the last in first out method. Now in a LIFO format, same like this breadth first search, we have a node status. Okay, okay, now in depth first search what we are trying to find, so we are trying to find, or we are trying to traverse the graph like in depth, something like this. Then we are, if there is no any connection, then we can move towards the previous parent, and then we can move next side. Okay, so we are trying to find the depth of graph. Okay, so we are traversing something like this. Now set your status equals to 1 in a ready state. For each node in a G, push the starting node A on the stack and set its status is equal to 2. Waiting step. Now we have to repeat this 2 step until my stack is not empty. Now pop the top node of N. Process it and set its status equals to 3. Now push on the stack all the neighbors of N that are in the ready state and set their status equals to 2. Now print all the nodes that can be reached from node H. Print all the nodes that can be reached from node H, including H itself. Okay, so we have to process our graph something like this. Okay, so now we have to start from H only. Okay, first of all we must have to create one adjacency list. Okay, in adjacency list what we are trying to do, you are aware with this. So we are just making one list which is related with our you can say direct connected nodes of particular vertex. Okay, now if they are saying like we have to start with H, then we first need to see the adjacent list of my H, that is E and I. So we must have to put that E and I into the stack. So DFS method uses stack. So push H onto the stack. Okay. Now push all adjacency neighbors from list and print top of the element. Okay, we are just putting that elements into this stack. So we have to put this E and I. Okay, now next. H, I, F, C, and G. Now how we can do it? So what are the adjacent node of my I? So adjacent node of my I is equals to F. So first we have to enter that node into the stack. Okay, and we can pop out this I. So we first start with H. So I have visited H, then I have visited I. Now it's time to visit the F as well as the F's adjacent node. Okay, so we can print or we can visit this F and check the adjacent of F. So C and H. So make the entry of C and H into the you can say your stack, but we can enter only C. Why? Because H is already visited, so we cannot enter that H. Now this is assuming something like this. Huh? This is my stack. So here we have E and here we have C. So topmost element is C. So we are trying to visit this C. So what are the adjacent list of C? We can visit this C. F is already taken. Now it's time to take the C. Okay, so what are the adjacent node of my C? So adjacent node of my C is B as well as G. So I have entered that B and G into the stack. So E is already there. C I can pop out. Then and only then I can check the adjacent list of that C. So C is pop out. Now I have a B and G only in my stack, and E is there as it is. So which one is the topmost element? So G is the topmost element. Okay, so next turn is Dijkstra. Okay, so now till over here the topmost element is B. Now find out the adjacent node of my G. So G adjacent nodes are B, H, and I. So check over here. H and I we had already taken. So B. So no need to enter the duplicated values over here. Okay. So now visit your B node. Okay. So G is already taken. So now it's time for B. So B. Okay. So B is printed on the screen as well as pop out from the stack. What are the adjacent node of my B? So adjacent node of my B is equals to E. So we have to pop out our E from the stack. So this is popping out from the stack. Okay, so the list is something like H, I, then F, then C, then G, G to B, and B to E. Okay, so what we are trying to do? We are trying to visit the every node. Okay, and finding the minimum path. Okay, E. So now what is the meaning of this? So we are trying to find the depth. C to sorry, you can say H to I to F, F to C. That means we are trying to go in a depth. Okay, so if we can say that A is the first node, starting from A you need to find the particular way to visit the every node. Okay, so what we have to do, we must have to enter that values into the stack starting from A. So instead of this H you need to find out the first adjacent list of my A. Okay, and we are trying to go in depth, not likewise. Okay, so this is your depth first search. Okay, so till now any doubt in breadth first search and depth first search? Okay, what are the applications? So finding a path between two specified node u and v of graph, finding whether a graph is connected or not. Now computing the spanning tree of a connected graph. Now what is spanning tree and how can you find that minimum spanning tree of particular graph? Will see it. Okay, now what is spanning tree and what is minimum spanning tree? Okay, so in breadth first search and depth first search, I guess there is no any confusion. Any doubt, any student? Yes, you can replay over here. Okay, now make sure whenever you are just trying to use the breadth first search, you must have to follow the queue concept and you must have to use the queue for finding the node, next adjacent node, and make the list. Okay, now next, if you are trying to find the depth of your graph, that means using the depth first search, if you want to find the list, then you must have to use the stack concept. Visit the node starting from given vertex, and turn by turn you need to move from that node to the next adjacent node, and whatever the value is present in the top of the stack, that values adjacent node you need to find next time. Okay, now minimum spanning tree. So a spanning tree of a connected or undirected graph G is a subgraph of G, which is a tree that connects all the vertices together. Next, a minimum spanning tree is defined as a spanning tree with weight less than or equal to the weight of the other spanning tree. Okay. Now we have one graph. Okay, now we need to take care, like there is no any you can say cycle should be there. We must have to visit the every node, okay, which is connected with each other. Right here we have a cycle, so we can not say that this is my spanning tree. Okay, so spanning tree, there is no any cycle, as well as we must have to visit the every node, and there is no any node which is not connected with any of your vertex. Okay, so we must have to connect the every node. Either we can connect like B to C or A to B, that is according to our graph. Okay, so according to this graph, if we want to find out the particular tree, spanning tree for this graph, we have a different kinds of situation like A to B, B to C, and C to D. Okay, second spanning tree, possible spanning trees. I am saying about possible spanning trees: A to D, right? D to B, and D to C. Okay, another one like A to C, A to D, A to B. We have already visited the every node, as well as there is no any cycle. So possible spanning trees are something like this. हमने सारे नोड को कवर भी, सारी वर्टाइसेस को कवर भी कर लिया, एज वेल एज साइकिल भी नहीं होने दिया, और जितनी भी पॉसिबिलिटीज है सारी हमने देख ली. ओके, इसके अलावा भी स्पैनिंग ट्री पॉसिबल है, लाइक ए बी डी and C, but the connection is something like this. Clear? Now what is minimum spanning tree? Minimum spanning tree, that means we have one spanning tree with us, but we must have some weight with us. Then and only then we can find the minimum spanning tree. Otherwise, we cannot. Now, so that spanning tree's meaning is something like, if I want to, sorry, this graph weight is something like, if I want to visit this A to C, then I can take weight like 4. I can traverse weight like 4. Now, if I want to visit this A to D, then traversing, you can say the weight is equals to 7. Okay, but if I can take a path like A to C, C to D, then the cost of that, you can say traversing technique is 4 plus 2 is equals to 6 only. Okay, so we are trying to find the minimum spanning tree which can contain the minimum cost. Okay, so as we had discussed, we have this many possibilities with us. So according to that possibility, what is the actual cost of your that particular spanning tree? So the this particular spanning tree's cost is equals to 3 plus 7, 10 plus 4 is equals to 14. Okay, so if you want to visit this every vertices with some particular weight, then you can say that total cost is equals to 40. Now next, if we can take this spanning tree with this particular graph, then the cost is equals to 6 plus 5, 11 plus 3 equals to 40. Now, if we can find the, you can say the spanning tree with this kind of weight, then it is 3 plus 2, 5, 5 plus 5 equals to 10. And if we can choose this path, 3 plus 4, 7 plus 2 equals to 9. So this is the minimum spanning tree. Okay, so the total cost is equals to 9 only. Okay, so we can choose this as our minimum spanning tree. Okay, which can take or which can give us the minimum cost. But here we have only, you can say 4 vertices. But if we have n number of vertices and n number of weight with us, how can we find this minimum spanning tree? So if we are trying to draw this kind of tree, then it will take too much time. Okay, so for that we have different kinds of, you can say algorithm with us. First, that is Krushkal's algorithm. To find the minimum spanning tree of a particular given graph, we have a different kinds of technique. So is there any doubt in this, like what is minimum spanning tree? Okay, so we have a first, you can say type with us named with Krushkal's algorithm, which can help us to find the minimum spanning tree. Now, first step, initialize sorting the ages by increasing age weight. Okay, so first what we are trying to do, we are just trying to write our age weight. Okay, so age weight, that means first find out the this kind of thing. Okay, let me open my notepad file. So step by step we can move towards the next one. And let me share my entire screen. Okay, I think my notepad is also visible to you. Is it so? Visible now? Okay, okay. So now starting with the this one. Okay. So according to this, we first need to take the connections of every node. Okay, I'm starting from A. So if I'm traversing from A to F, let me E comma F. So it will take a weight like 10. Okay. Now, if I'm taking the path from A comma B, it will take a cost like 8. Okay, now A, comma, H can cost 5. Okay, now A, F, B, and H. F, B, and H I have visited. Now starting from B. So if we are trying to move from B to C, B to C, it will cost me 4. B to F, 4. B to A, 8. And B to H, 4. B to E, 4. Okay. Now next I'll take C. Okay, so we are trying to make the list of adjacent node with value. C to D, 3. C to F, 3. Then C to B, that is 4 only. Now D. So D to E, sorry, B to E is equals to 1. B to G is equal to, B to G is equals to 2. Sorry, 2, okay. And is there any missing node? Yes, D to F equals to 6. D to F is equals to 6. Okay. Likewise, I have entered the every values in my, you can say, list. Okay. So now you can see over here, we have this many connections with us. Okay. Now after this, what we are trying to do, like if we had make the entry of every nodes with adjacency list, right? What we are trying to do, we are just trying to sort it into the particular order, like from ascending order. Okay, so you can see over here that B to C, B to E, B to F, B to H. So B to C, F, H, E, and A. Okay, so what we are trying to do, so here we can first find out the minimum node. Okay, so it will take time, so we can make these entries, right, from 1 to and 1 to next to this next to this, right? So what we are trying to do, so we can just trying to make the entries in a particular order. So in a particular order, that means what, like if we have a minimum weight with connection with D to E, so I am making the entry like D to E is equals to 1 weight. Okay, so it will feasible for us, right? So we are trying to do that. Now next is, next minimum weight is equals to D to G, weight is equals to 2. So D to G, the weight equals to 2. Now minimum weight is equals to 3. So this is 1, 2, 3, and 4. How can we take this? So if we are trying to visit from D to C, it will take the node equals to 3. Right. So first we are trying to take the node equals to E to G, which can cost the 3. Okay. Now next is C to D. C to D, that is also 3. So we can take it. Now C to F. C to F, that is also 3. So we can take it. Okay. Now for B. So B to next every adjacent node we have, you can say 4, 4, 4, and 4. Right. So we had taken it. Now other than 4, the next maximum value equals to 5. So A to H. So we had A to H. Now the next is 6. Right. So the connection of F to D to F. Okay. And the next is A to B as well as A to F. A to B and A to F. Okay. Now we had initialized and we had just make the entries of a particular node. Okay. So now one by one we have to visit the every node. So D to E with minimum age. Yes. So we can take it. Now D to G. Can I connect this D to G with 2 weight? Yes, because there is no any cycle. So we can connect it. You can see over here, huh? This is the sequence, like how we can take the H. Okay, and do not generate the cycle. Now next, E to G. This E to G. So E to G will take the 3 as a R, you can say the next age. So can we take this E to G? No. Why? Because otherwise it will make a cycle as well as it will cost 3 to visit my E to G. So what we are trying to do, we are simply not taking that node. Okay, now next is C to D. So what is the cost of C to D? So C to D, the cost is equals to 3. Is there any cycle? No. So we can take it. Now next is G to H. So G to H. Can we accept this G to H? Yes. Why? Because the cost is also minimum and there is no any cycle. So we can add it over here. Now next is C to F. So here the cost is from C to F is equals to 3. So we can take it and there is no any cycle. Now B to C. So if I'll take this B to C, is there any cycle? No. So we can take it with the minimum cost equals to 4. Now B to E. So this is my B to E. If I'll take this B to E, it will make a cycle. Can I take this B to E as in my next choice? No, we cannot. Why? Because it will generate the cycle. So we can simply avoid that connection. Okay, now next B to F, this one. Can I take this B to F? No, we cannot. Why? Because it will also create the cycle. So we can simply avoid that. Now B to H. Can I take this B to H? This? No. Otherwise it will make the cycle this one. Okay, so we can simply avoid it. Now A to H. A to H, which will it will cost me as a 5. And if I take this something like this, is there any cycle? No. So we can take it. Okay, now we have a next is equals to D to F. So D to F, the cost is equals to 6. So we cannot take. Why? Because till this node we had this you can say visit the every vertices as well as with the minimum weight as well as the no cycle in the available node available list. Okay, so this is the list of our particular you can say visited nodes one by one with the this value. Okay, so now the next is you have to give the total. So you can add the every numbers which we had discussed over here and write down the total cost of that particular tree. So this is your Krushkal's algorithm minimum spanning tree method. Okay, so this is the you can say your solution of our this is my graph and this is your minimum spanning tree which we had discussed using the Krushkal's algorithm. Okay, so till now any doubt? Okay. Okay. So the next is Prim's algorithm. Using this Prim's algorithm, we can find the minimum spanning tree, like shortest path from source to your destination. Okay. Now here, the source is B, destination is my A. We have to find the minimum spanning tree of a given graph from D to this A. Okay. So first step of your Prim's algorithm is you have to write the table like current, distance and previous. Okay, so yes, one thing I forgot to tell you is like in if in examination they will ask related with the Krushkal's algorithm, you need to first make this table and you have to write the tree after each and every step. If you have taken this age, then write down this D to E I am taking as a weight 1. Then D to G, that means I'm taking this connection with weight 2. Yes. And if you cannot take this 3, then make that cross and do not write that age over here. Right. Okay. So you need to work something like this, and don't forget to write this one. If you have forgot to write this, it will not a proper answer. Okay. And at last, you need to define the total cost as well as the particular minimum spanning tree. Okay, so same like this, we have you can say minimum spanning tree using the Prim's algorithm. So in a Prim's algorithm, first what we are trying to do, we have every vertices list with us. Okay, and there has three you can say the we have a three different columns. One that is current, second that is distance, and third that is previous. Okay, so here for a particular time for a while and for you can say till I didn't visit any node, the by default distance of every node is equals to infinite. Okay, so we don't have any you can say the particular values till now. Okay, so our source is D, destination is A. So we can visit or we have to start visiting a node from D only. So D. So we need to take that D distance is equals to 0. First time the distance is equals to 0. Okay. Now start with the source node, say the D. Okay. Now from this D to C, we have a distance like 3, 6, 2 and 1. So now we can change this infinite value with the particular given weighted values. Okay, so what is the answer? So if we are trying to move from this D to C, it will take the distance equals to 3. If we are trying to move from D to F, it will take the distance equals to 6. Okay, and previous that means I can't visit this node from this D to next node. Okay, so that's why it is D. So update your distance of adjacent unselected nodes. This is not selected node, right? This is till this is unselected. Now how we can select it? So now find out the minimum value which is available from D to the next adjacent node. Which age can contain the minimum you can say value, that is D to E. So where we have D to E, so this one, right? So we can select that node. Other are as it is. So no need to change that value. Okay, so now we had visited this E. Okay, now it's time to find the adjacent node of E with the minimum distance. So now starting from E, we have to find the next adjacent node of my E. So here we have adjacent nodes with E to B. Then other nodes are as it is. Okay, this is 1, 2, 4, 6 and 3, because these nodes are unvisited, still these are unselected. So out of this 2, 6, 3 and 4, we have to find the minimum one. Okay, so which one is minimum? So out of this one, dotted line, 2, 3 and 4, this 2 can contain the minimum value, right? So this one is also visited, so not required to visit this. Okay, so now unselected nodes are 6, 2, 3 and 4. So out of this 2, 3, 6 and 4, which one is lesser? So this one. So we can select this D to G with 2. So we can update that distance with T. So I have selected it. Okay, so now where I can at which place I am? So I am at this G. So now find out the adjacent node of my G. So according to this, we have only one edge between this G to H, that is with 3. So now we have a value like 3, 4, 6 and 3. Okay, so now select the minimum out of this particular four values. So which are minimum? So you can say this D2C is the minimum. Okay, you can select this D2H also. Yeah, I have selected this D2C because this D is the my source node. That's why. Okay, you can select this G1, but we have you can say the definitions, like we have to find the node from D to A. That's why. Okay, so we have selected this D to C. Now still the visiting nodes are sorry, unselected edges are 6, 4 and 3. So now find out the particular values, adjacent values from C. तो C के adjacent कौन कौन से है? Only F. Okay, so out of this we have a value 3, 4 and 3. So we can select C to F. Okay, now find out the adjacent node of F. So only one, that is 10 and sorry, F to A. So अब देखो in 10 and 3 and 4 में से कौन सी lesser value है? So this one G to H. So we can take this. Clear? Okay. Now find out the next adjacent from H. So H के adjacent like 5. Okay, we cannot take that 10. Why? Because otherwise it will make this cycle. Okay, so unselected are 5 and 4. So we must have to take this one, E to B. Post is equals to 4. Okay, and now the adjacent is only remaining with A node. Okay, so this is the total, you can say, your minimum spanning tree using the Prim's algorithm. Okay, and now you can take the total of this particular value. Okay, and you can say that this is the minimum value of from D to particular A node. Okay, so D to G, G to H and H to A contain the minimum spanning value to traverse from that to the next one. Okay, you can find it. So if I take from D, E and B, it will not give me the A. So if I take this path D, C and F, it will not give me the particular value. So we can choose only the D, G, H and A traversing from this D to my A. Okay, so this is your particular tree. Now these two are the examples. Okay, now next is Dijkstra's algorithm. Okay, so till now, any doubt in this? Any student having any doubt in Prim's as well as in the Krushkal's algorithm? Okay, out of that two algorithm, Prim's and Krushkal's, right? In which you can say algorithm, we are just trying to take the ages from minimum to the maximum. We are making the adjacency list from minimum value to the maximum. In which algorithm we are performing that thing? कौन से एल्गोरिदम में हम यस उसका नाम क्या है फर्स्ट वाले का फर्स्ट वाले का नाम क्या है प्रिम्स और क्रुशकल्स Prims or Krushkals? That is Krushkals. Okay, it's fine. KRU. KRUSH? Krushkals. Okay, no issue. Don't worry. Okay, now let me start one more time with the next. Okay, and in Prim's algorithm, the first step to generate the table of Prim's algorithm's adjacency list is the first step. फर्स्ट स्टेप क्या था प्रिम्स एल्गोरिथम का? अगर हमें टेबल जनरेट करना है, टेबल में मैंने 3 कॉलम लगा दिया एज वेल एज सारे वर्टिसेस के नेम लगा दिए, यस, करंट, डिस्टेंस एंड प्रीवियस, बट उसमें वैल्यूज क्या फिल करनी है और स्टार्ट कहां से करना है? Yes, first step we have to put the distance as infinite in every particular data. Okay, and we have to start it from the source ports. Okay, let me share one more time, otherwise it will. Dijkstra. Yes. Okay, so now let me share my screen with the next one. That is Dijkstra's algorithm. Okay. Now, Dijkstra's algorithm is single source shortest path algorithm. The single source shortest path algorithm, that means we have only one source with us and we can find the path from that to the next one. Okay, so now the problem of finding the shortest path from a source vertex T1 to all other vertices in the graph, right? How we can find it? So we have the solution with us, right? Like every time we have to find like 10 or 3, then find out this 3 or 1. So if I'll take 10 and 1, then the total is equals to 11. If I'll take this one, then 3 plus 4 equals to 7. The next equals to 7 plus 2, 9, and 9 plus 7. So if I take this one path, it will take a lesser value, right? So it is, you can say, too much, you can say, complex to find out the particular values data. Okay, so what we are trying to do, so using this Dijkstra's algorithm, we can solve this problem. Okay, so according to that particular weight, we are just trying to write down the matrix with a zero initialization with the infinite distance. Okay, so assume like T1 has a distance is equals to T1 to T1 equals to 0, T2 infinite, 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 infinite. Okay, forget about this distance. Okay, you can take this a screenshot, huh? So that's why it is a bit easy for you to choose the particular path every time, otherwise I need to shift from previous to next slide, that's why. Okay, now first, starting from T1, we have two adjacent values, that is 3 and 10. Which one is minimum? This one is minimum, so make it as a 3, and next that is 10. Okay, so now the distance is you can say replaced with the particular distance. Okay, so infinite is replaced with 10 and 3, as well as make the entries in the table in a new row. Make sure in a new row. Okay, so now next step, which one is minimum? So your 3 is minimum. So still this is the unvisited or unselected value. Okay, now find out the values or adjacent values from this T4. So we have a 3 values with us, like 4, 8 and 2. Okay, so the distance you need to change. Okay, so if I am traversing from this to this, the total distance should be 3 plus 4 equals to 7. And if I am traversing from T1 to T2 directly, then the distance is equals to my 10. So which one is greater? So 10 is greater. So I cannot choose that path, but I can select this one path because the cost is equals to 3 plus 4, 7. So I am just removing that link and I am just remaining with this 2. Okay, now from this T1 to T4 to T5, if I want to reach, then what is the total cost? So 8 plus 3 equals to 11. So I am replacing my infinite with 11. Now if I want to reach this T6, so the cost is 3 plus 2 is equals to 5. Clear? Now which path I can choose? So I can take the minimum value path, that is 4, 8 and 5, 7, 11 and 5. Sorry, 4, 8 and 2, 7, 11 and 5. So I am taking this one path. Okay, so T1, T4 and T6. So replace your T6 with the 5 one. Okay, now you can find the adjacent node of your T6. So T6 can connected with T5 only, and the cost of that T5 is equals to 9. Okay, so now find out the total cost, that is 3 plus 2 equals to 5 and 5 plus 9 is equals to 14. So 14 is greater than 11. So I cannot choose this one path. So which I can choose? So I can just removing this and I can choose this path because out of this 4, 8 and 2, the minimum is equals to 4. Okay, now find out this T2's next node. T2's adjacent are 1 and 2. Okay, now out of this 1. So if I am trying to move this side, then it will make cycle. So we cannot take that. If I am trying to choose this path, it will also make a cycle. So I cannot choose this one. So now out of this, we are remaining with this 2 only. Okay, why we can remove, why we are trying to remove this? Because it will cost me higher as well as it will generate the cycle of T4 and T2. Okay, so if I want to reach this T5, what is the total cost? 3 plus 4, 7 plus 2 equals to 9 and 3 plus 8 total equals to 11. So which path I can choose? I can choose this T1, T4, T2 and T5. Right? So enter your T5 over here. Okay, so this is the shortest path solution using the Dijkstra's algorithm. Okay, now how your Dijkstra's algorithm will work. So Dijkstra's algorithm is a solution to the single source. Okay, before we'll moving towards the that one, is there any doubt or any confusion in difference between your Dijkstra's, your Krushkals and Prims? Any confusion? Yes, any doubt in this? Okay. No doubt, right? Okay, so we can start with the next one. That means how we can say this or how we can write this algorithm. So Dijkstra's algorithm as a solution to the single source shortest path problem in a graph theory. Now work on both directed as well as the undirected graph. However, all edges must have no negative weights. Okay, this is the basic thing. Now, step number 1, distance to your source vertex is equals to 0. Set all other equals to infinite. Yes, we had discussed this. Now, S, the set of visited vertices is initially empty. Okay, so there is no any value in that particular, you can say, node. Okay, now the next Q is what? The Q initially contains all vertices and initial distances. Okay, that means from that node to which node I need to visit, that is initially updated or initially available in my queue. Now in a step number 5, you need to repeat it. Why? Because we must have to visit the every vertex from that source. Okay, do not consider like from that adjacent node to that particular distance, but starting from your first source node to reach at the last one, what is the total cost? Okay, select the element of Q with the minimum distance of Ti. Now add your Ti to the list of visited vertices S. That S is we had discussed, which we can make entry over here. ठीक है, जितने भी नोड के आप विजिट कर रहे हो वो सारी विजिटिंग नोड की एंट्रीज यहाँ पे होनी चाहिए. अब इस 7 और 11 में से 7 आपने लेस लिया है, दैट मीन्स हमने विजिट कर लिया T2 को, सो वी मस्ट हैव टू एंटर दैट T2. नाउ अनविजिटेड नोड इज इक्वल्स टू T5. अब चेक करो यहां से लेके T5 तक जाने के लिए कौन कितनी कॉस्ट लग रही. डोंट सी द कॉस्ट लाइक 4, 2 एंड 8, but find out the total cost. 3 plus 8 equals to 11. 3 plus 4, 7 plus 2 equals to 9. So 9 and 11. Out of that two values, 9 is lesser. That's why we can choose this path. Okay, so we can add this T5 into the particular list. Okay, now here in this step number 7 is what? We have to add that particular visited node edges weight. I'm saying weight, हम उसका distance और weight add कर रहे, ना ही adjacent का, but source से लेके destination तक का total ले रहे. ठीक है. Now for all vertices belongs from neighbors of Ti. ठीक है, उस नेक्स्ट नेबर से लेके नेक्स्ट वर्टाइसेस तक हमें ट्रैवर्स करना होगा, तो ही हम उसका टोटल फाइंड कर पाएंगे. That's why visiting check the distance V is greater than distance of that particular source node plus W of Ti, B. ओके, सारा का सारा टोटल करके उसका ग्रेटर हो रहा है कि नहीं वो हमें चेक करना है. नाउ इफ shortest path found, then set new value of shorted path. Otherwise discard that node simply and print it on the screen. Okay, so first write down your enrollment number over here and then we'll move towards the next one.
आराम बेड़ा
Yes, Daria. Daria, just mute yourself. Okay, so first let me draw one small graph for you. So that's a bit easy for us. Okay, one by one. So it will be easy for us to understand. Okay, so weight of this is 6. Weight of this particular node is equals to 4. And next for this is 11. This to this, we have 3. Here we have this graph is 4. Warshalls algorithm. Okay. Now, how our Warshall's algorithm will work? So, is my PPT is visible to you? I guess no. Okay, so how our Warshall's algorithm, all shortest path pair is working. Okay, okay. So all pair shortest path. Okay. Now path matrix, how we can design it. So the adjacency matrix equals to A. Path matrix P is equals to A plus A2 plus A3 plus up to N. Okay, and how we can define our path matrix with 0, 1, 2, and N. So we'll discuss it. But first, if we want to find the particular value of a particular data, then Pk of ij is equals to 1. If there is a path from that particular node to the next node, path should not use any other vertex except v1, v2 up to vk. And p of k ij is equals to 0 otherwise. Okay, now don't see it first. Okay, so over here, first we have to design one matrix which is named as A0, and 0 is you can say yes, like this. Then this much zooming is fine. Is it visible to you? Okay. So first, A of 0, that means our adjacency matrix, which we had already, you can say, the discussed. So how we can write it? So first, let me write 1, 2, 3. Okay. Now, here we have a column 1, 2, and 3. Okay. Now this is my column, and these are the row. Okay, rows value. Now from 1 to 1, is there any path is available? From 1 to 1, self loop. Is there any self loop? No. Then the value is equals to 0. Now if I want to reach from 1 to 2, is there any value? Yes, 1 to 2, that is 4. So we can write it like 4. Now 1 to 3, that is 11. So you are aware with this. So simply I am writing the values 6, 0. 3 to 1. Yes, 3. There is no any value, and 3 to 3, that is 0. So here what we have to write? Here we have to write infinite. Okay, so why we have to write infinite? So instead of infinite, I am writing the dollar. Dollar is equals to infinite. Dollar is equals to infinite. It's infinite, that means there is no any path from 3 to 2 direct path. So that's why we have to make it as infinite. Okay, now this is what your A of 0th Warshall's algorithm path matrix. Okay, now if this is our path matrix, then first time we have to see only this much path, direct path. But second time we must have to see the indirect path also. And indirect path, that means what? From that particular node to via path we need to take. Via path, that means A of 0, 0 to 1. A to 0, 0 to 1. Okay, something like this. Let me draw that one so you can easily understand.
So if I'll write downwards, then our figure is not visible. That's why I have to write over here A1. So 1 is like this. Okay. So now what we are trying to find, so we are trying to find the matrix of A1. Now if you are trying to find matrix of A1, that means one is the intermediate vertex. Okay, so intermediate vertex, that means what? Starting from, if I want to find out the path from 1 to 3, so 1 should be the intermediate node of that particular vertex. That means I want to find the path from 1 to 3. So 1 to 1 and 1 to 3 likewise. Okay, so let me write that here we have 1, 2 and 3, and downwards also we have 1, 2 and 3. Okay, so now over here, if we want to find out the path from 1 to 1, we cannot directly write. So what we have to do, we first need to find that 1 to 1 path we want to find. So for that, first we need to find path from 1 to 1 plus 1 to 1. But there is no any self loop, that is equals to 0. And previously it is equals to 0, so we can write it is equals to 0. Now second time I want to find out the path. I want to find out the path from 1 to 2, but 1 is the intermediate node. So 1 to 2 I want to find the path, but 1 should be the intermediate node. So how we can write? First you need to find the path from 1 to 1 plus that 1 to 2. So what I'm trying to say you is, am I clear with this? No? Yes, okay. मैं क्या बोल रही हूँ कि हमें अगर एक नोड से दूसरे नोड तक जाना है, पहले हमें 1 को इंटरमीडिएट रख के जाना है, देन 2 को इंटरमीडिएट रख के जाना है, देन 3 को, राइट? सो what is the path from 1 to 1? So 1 to 1 is equals to 0. 0 plus what is path from 1 to 2? So the direct path from 1 to 2 is equals to 4. So 0 plus 4 equals to 4. Previously it was 4. So I am writing 4 over here. Now I want to find the path from 1 to 3. 1 से लेके 3 तक जाना है, but make sure कि 1 को हमें intermediate रखना ही है. So 1 to 1 का path find करो, then 1 to 3 का path find करो. And what is the answer? 1 to 1 is equals to 0. 1 to 3. 1 to 3 का 11. Right. So total is equals to 11. So there is no any change in this. Okay. Now, here 11 only. Now we have to find the path from 2 to 1. Okay. So अगर मैं ये delete कर दूं, then it's fine. Okay, let me write over here. I want to find the path from 2 to 1. 2 से 1 जाना है, but the situation is 1 को intermediate रखना है. That means 2 से 1 जाओ पहले, then जाओ 1 से 2. Okay, समझ में आ रहा है? Like मैं ऐसा कर रही हूँ यहाँ पे 1 2 3. मुझे जाना है 2 to 1. So if this is 2, this is 1. ठीक है, पर मैं ऐसे डायरेक्ट नहीं जा सकती. पहले मुझे जाना होगा 2 से 1 तक. ठीक है, then 1 से 1 तक and then 1 to 2. Okay, so that means मुझे intermediate node किसे रखना होगा? 1 को. 2,1 इक्वल्स टू 2 से 1 जाओ, देन जाओ 1 से 1। ओके, इन दोनों के बीच में एक 1 विजिट करना होगा आपको। It will be 2 1 and 1 1. Yes, exactly. Okay, that was my mistake. Make sure जो भी यहाँ पे है वो यहाँ आना चाहिए, और जहां पे आपको जाना है वो लास्ट में आना चाहिए, और बीच में जितने भी दो नोड आ रहे हैं वो सेम होने चाहिए, राइट? सो द टोटल इज इक्वल्स टू, यू कैन से 6 प्लस 0, 2 to 1 कितना है? 2 to 1 इज 6। आगे वाले मैट्रिक्स में देख लेना, हमेशा आगे वाले मैट्रिक्स में देख के ही लिखो। एंड 1 to 1 इज इक्वल्स टू 0, सो आंसर इक्वल्स टू 6। Okay, now I want to move from 2, 2, but we cannot directly move, but हमें किसको इंटरमीडिएट रखना होगा? सो 2 to 1 प्लस 1 to 2, ऐसे जा सकते हैं। 1 को तो बीच में लेके ही जाना। नाउ 2 to 1 का पाथ क्या था? 6 प्लस 1 to 2 का क्या है? 4। Am I doing wrong? No. So answer is equals to 10. पहले ये कौन सा था? यहाँ पे अगर मैंने 6 लिखा है, 6, okay. So पहले ये कौन सा था? 2 to 2 का पाथ क्या था? 0। देख लो यहाँ पे 0, और अब हमें क्या मिल रहा है? 11। We are trying to find the minimum, so we cannot change this 0 with 10 because this is already minimum, so we cannot write this 10 over there। अगर वो मिनिमम मिल रहा है तो ही अपडेट करो, अदरवाइज एज इट इज रखना है। नाउ नेक्स्ट इज 2 to, हमें मूव करना है 2 to 3, 2 to 3, बट द सिचुएशन इज 2 से पहले 1 जाओ, उसके बाद 1 से 3 जाना है। 2 से 1 का पाथ क्या है? 2 to 1, दैट इज 6, प्लस 1 to 3 का देखो, 1 2 3, दैट इज so answer is greater than your 2, so we cannot take this value। okay, so 2 as it is हमें लिखना होगा। clear? Now if I want to find the path from 3 to 1, first we have to visit 3 to 1 and 1 to 3। पहले 3 से 1 जाओ और फिर 1 से 3 जाओ, ठीक है? 1 से 3 वापस जाओ, कौन सा आंसर मिलेगा आपको? only, okay। नाउ अब इसका आपको देखना होगा, लेट मी राइट 3 to 2 जाना है मुझे। so intermediate node is 1, how can you find? this is the intermediate node value 1, so 1 को आपको intermediate रखना है, that means 3, 1 plus 1, 2। आगे वाले मैट्रिक्स में देखो, 3 to 1 क्या मिल रहा है मुझे? 3 प्लस 1 to 2 क्या मिल रहा है? 1 to 2, that will be 4। so what is the answer? Answer equals to 7, but previously it was infinite, so infinite is greater than 7, so we have to update our table with this value 7। clear? So this would be the major change when you are trying to write the data। जीरो से तो ग्रेटर कोई वैल्यू आ ही नहीं सकती. What is the difference between this? Clear? This is 7 and 7 is less than infinite. So we can take 7. Here this is the updated value. Okay, now according to this matrix, you have to write the next matrix A of 2. Write down the matrix of A of 2 and you have to give me the changed value. Is there any value changing in this? Now you have to write A of 2. 2 को आपको इंटरमीडिएट रखना है. Right, 1, 2, 3. 1, 2, 3. Okay, now यहाँ पे आपको एंट्री करनी है पर मेक श्योर कि आप जब भी कोई एंट्री लगाओ तो उसमें देखना है कि कोई भी डेटा अपडेटेड हो रहा है या फिर नहीं. कौन सी वाली मैट्रिक्स में देखना है? A1 में देखना है. राइट. सो नाउ इफ यू वांट टू ट्रैवर्स फ्रॉम 1 to 1, you must have to take a path like 1, 2 plus 2, 1, and you need to write the answer. Clear? Students, I am asking to you what I am trying to say. Am I clear with that topic? Okay. Okay, now here if you are trying to make the entry, what would be the answer? So you can say first 0 as it is, 4, there is no any change. Here we have a change. Like this 6 will be now working, you can say your 11 will be updated with 6. How can you say this? So let me write that thing. 1, 2 plus 2, 3. You need to traverse something like this. So 1 to 2. See over here, 1 to 2, the value is equals to 4. And 2 to 3. So 2 to 3, value equals to 2. So the answer equals to 6. But previously it was 11. So this 6 will be updated, updated instead of 11. Okay, other values are same. There is no major change in this. 607, 602 and 370. Now try to write the next matrix, which is A of 3. जितने भी नोड है उतने मैट्रिक्स बनने चाहिए. Okay, and in that matrix I guess there is 1, 2, 3, 1, 2. So I guess 0, 4, 6, there is no any change because it's already smaller. Now in this 2, there is change. Okay, so let me write that thing over here. Okay, so here we have a small change. Okay, what would be the change? So in this case, if I'll 2 to 1 plus, no, sorry, 2 to 3, 3 plus 1. Three, two, 1. 2 to 3, यहाँ पे देखो 2 to 3, that is 2. 2 plus 3 to 1, that is 5. Answer equals to 5. Previously it was 6, so here we can update it with 5. Other values are same. This is your, you can say, the minimum value with each and every pair I have matched, and the answer is minimum value only. Okay. Yes, it's 2 to 3. Okay. Now, if I have one more node with me, like 4, in that case, you have to take A0, A1, A2, A3, and A4 also. Okay, and whenever you have just write this entire algorithm or this entire question, you must have to write this table every time, okay, with updated value. And if you are trying to write this A3, you need to keep in mind that now this will become your question. Okay, so this A2 you need to take care as your question, right? If you want to find the path from 1 to 2, you need to take that value from this only. Why? Because this is already updated. If you are trying to see it in this A0, this is infinite, but here we have a 7, that is minimum value. So the answer may be changed. So every time you need to see the A of value minus 1 table to find the new table. Okay, so is my PPT is visible to you? Okay, so here we have a next question, or maybe you can say the same method but the bigger one question. So what we are trying to do, they are just trying to find the 0 1 0 1, which is the, you can say, the first matrix. Then value will be updated with your, you can say, the given weight. Okay, like 1 to 1 0, that is 1 to 2. There is no path, that means it is infinite. Okay, but self loop is equals to 0, but there is no path, that means infinite. Okay, now we need to take the table as L of 0, right? And then how you can do it? So now you can easily verify it with this. Like if you want to define the table of dk of ij, you have to take the minimum path from dk minus 1. मतलब कि अगले वाले टेबल में से देखना है. That means I of j comma d k minus 1 I k. समझ लो कि आपका I जो है आपको कहाँ पे रखना है? As a middle one. Okay, so you can find the path from k to j particular path. Okay, आगे वाले टेबल में से देख के लिखना है, not the defined one. Okay, so this will be the changed when you are trying to perform this algorithm. Okay, so this is the thing. Okay, this is the algorithm, you can say. And in this algorithm, what they are trying to find, like if you are trying to find the array, then Warshalls can be worked with L of 1 to n, comma 1 to n, because we have to check the every row column value. That's why. Okay, in this array, we have 1, 2, and 3 major array. T is equals to 0. Destination is equals to L. That means आगे वाला जो भी values है वो हम उसके D में enter करेंगे. Now your K is equals to 1 to n. That means जितने भी vertex से उतने table बनने चाहिए. First for loop. Second for loop for I, That means every row will be you can say matched with every column, 1 to 1, 1 to 2, and 1 to 3. Then for third one, we have to take the each and every row's value with the particular previous table value. So what we have to do, we need to k as an middle one. So if our I of k plus k of j is less than my previous one table's value, then take it. Otherwise, previous one table's value as it is you have to put. Okay, if I first explain this algorithm, you cannot verify it with the implementation. That's why I have explained it afterwards. Okay, so I guess there is no any you can say confusion in this. So you can see over here. Now let me share the screen with next chapter, that is file hashing. Okay, now in file hashing, what we are trying to you can say explain. Okay, file structure and your hashing function. Now hashing, that means whenever we are just trying to insert something or we are just trying to store something into our memory, right? Different kinds of algorithm, different kinds of methodologies are there. Okay, so to store the data, to retrieve the data, right, according to our file. Okay, so that is the main, you can say, the concern of our this chapter. Okay, graph chapter is completed. So now we are in the last second chapter. In last chapter we had discussed in the last lab. Okay, so the most applications collect the huge amount of data like bank accounts, college admissions, scientific experiments, etc. So files stored on a computer are a good alternative to store. But primary storage versus secondary storage, we need to take care of that things. Less time, less space versus more time and more space, right? So we need to define the data structure, like it will not you can say in a worst case it will give us the efficient result. Okay, so we need to take care while we are just choosing that kind of you can say the data structure. Now a data structure could be present both in RAM as well as in the disk. Now technically the file structures are more standardized, especially if one wants to allow the third party application or a newer version of the same application to open the file. Okay, so there is no any technical issues should be there when we are just trying to approve towards the next version. Now data structures can change between application versions and there is no need of compatibility, right? So now in most of the cases when we are trying to use the binary files structure, the basic organization elements are pages and physical links, right? Like from this page to this page I need to connect, from this computer memory disk pages, that means you can say the some kind of memory space, right? And we have to map that memory space with the particular you can say the data, right? Say for example if we have function call, so what we can do, so in function call we are just trying to jump from that location to that particular function body. ठीक है, आप लाइन पे ही तो फंक्शन लिख नहीं रहे हो, आपका फंक्शन बॉडी किसी और जगह पे स्टोर होगा, आपका फंक्शन कॉल मेन में है. सो जब भी आप फंक्शन कॉल करोगे उसके साथ उस मेमोरी चंक के साथ आपको मैप करना है और उस पर्टिकुलर डेटा के साथ आपको रिट्राइव भी करना है, कुछ स्टोर भी करना है. ओके okay, so that's why we have to define this kind of structures. Now every file contains the data which can be organized in a hierarchy of a systematic organization, which is known as a data field, record, file, as well as the directory. This is the hierarchy of your data. Now what are the file major attributes? So every file is stored in a directory in a computer system. Now each file is having the list of attributes associated with it. You are aware with this. The they state how to use that file to any software program looks up the directory, right? अगर मैं किसी प्रोग्राम को किसी सॉफ्टवेयर के लिए यूज कर रही हूँ तो उस डायरेक्टरी में से रिट्राइव कैसे करना है, कौन से एट्रीब्यूट के साथ मुझे रिट्राइव करना है, कौन कौन सी फाइल्स को मुझे कनेक्ट करना पड़ेगा, कौन से लोकेशन को एक्सेस करना पड़ेगा, दे ऑल आर कम्स अंडर दिस डेटा फील्ड, record, file and directory, right? So just like hidden files are not displayed in those when we are applying the dir command. Okay, so now these are the main attributes. You can say file name, string of characters vary by operating system, file position, position where the next read or write operation can be performed, file structure where text file or binary file, right? They both are different. Now file access method, that means how you can access that record sequentially or randomly, or maybe the you can say direct accessing, or how the method is. Okay, so attribute flag, a single byte is used to specify 6 flags attached to a file. If it is read only, the byte is something like this, hidden something like this, system, volume label, directory, or maybe the archive. Okay, now in file attributes, if it file is opening in the read only, you are aware with this, right? Can't get deleted or modified, get message like access delete. Now if it is hidden, then not displayed in a directory listing. जो भी आप डायरेक्टरी को एक्सेस कर रहे हो, राइट, दोज में से, और जब भी आप किसी फोल्डर को एक्सेस कर रहे हो डायरेक्टली वो आपको डिस्प्ले नहीं करेगा, बट उसके लिए आपको क्या चाहिए होगा, उसकी परमिशन चाहिए होगी, ठीक है? मतलब कि आप जब भी कोई डेटा को एक्सेस कर रहे हो, एट दैट टाइम यू हैव अ परमिशन टू एक्सेस दैट पर्टिकुलर हिडन फाइल्स, और अदरवाइज यू नीड टू गिव द एक्सेस, लाइक आप कर सकते हो, ठीक है? नाउ system, that means important as used by system and must not be altered or removed, so more than it is read only. Now volume label, that means every disk volume is assigned for identification mainly at the time of formatting, right? आपको आप उसमें कुछ भी चेंज कर रहे हो, फॉर्मेटिंग कर रहे हो, राइट, उस टाइम पे आपको कुछ असाइन करना पड़ेगा, कुछ आइडेंटिटीज देनी पड़ेगी, then and only then it can change it. Okay, now the what is directory? So extra bit of a differentiate directory from file. Now in a directory listing, it is used to specify subdirectories theoretically by changing this bit, but we can convert a file to directory, but practically results in fail. Now what is archive? So backup program uses it by setting 1 and 0 and 0 to 1 to have the latest copy. Okay, so we'll see it in the next session, next upcoming session. So this is our last chapter and 2 to 3 topics are remaining of that chapter. So today we had discussed the graph, entire graph, 4 types of minimum spanning trees algorithm: Dijkstra's, Prim's, Krushkal's, and Warshall's. Okay. So till now, any doubt in any of that example? I'm asking to everyone. You can replay over here if you have any doubt. Very good, no doubt. Okay, is there anyone who can't write that number at that time? Okay, so you can just read it once, and if you have any doubt in this, you can